Okay, this chapter we are jumping around chapter 9. We're doing 9.3 because it's extremely small lesson. There isn't that much material and it's a half day, so I'm jumping here first and I have to skip some sections, but we are in chapter 9. So let's get started. You're doing 9.3, page 412, number 1 through 33 odd. Today we are looking at equations with absolute value. So just a quick review. We went through this in chapter 3. Most of this should be a review. When we talk about absolute value, what we're really talking about is your distance from 0. So if I have 1, 2, 3, and 1, 2, negative 3, if I were to take a ruler and measure from here to here, it would measure 3 units, not negative 3, because distance isn't a negative value. And the same thing goes if I go, remember, if absolute value is distance from 0, if I go from 0 to 3 and I take my ruler, it's going to also measure 1, 2, 3. So we have 2 values when we are using our absolute value and we say it's equal to 3. We know that it could be 3 units this way or 3 units this way. All right, so when we have the absolute value, knowing that we have both ways, we have 2 possible solutions when we use absolute value, 5 or negative 5. 5 or negative 5. But on the other hand is, again, remember, this means distance from 0. So if 5 is here and negative 5 is here, is there any measurement, if this is 0, that will give me negative 5? And the answer is no, because distance can't be negative. Even if I pulled out my ruler and I measured from here to here, it would measure 5 units. Okay, so in this case, when you have an absolute value that is equal to, not a negative on the absolute value side, when you get the absolute value all alone, just like you're isolating a variable, when it is equal to a negative, you say no solution, because there is no measurement that equals a negative. Okay? Now, we're going to treat our absolute value just like it's a variable. We have to get it alone. Okay, this is alone. And so we know that if it's 5 units, if this whole chunk in here equals 5 units, those 5 units could be from here to here or from here to here. Okay, the 5 units it could equal. So we have 2 possible answers. So what we're going to do is we are going to, once we get the absolute value alone, we're going to branch it into 2 solutions. Okay, branch it into 2 solutions. Set one equal to the positive 5 and one equal to the negative 5. And then we actually solve it. So I have n plus 1 equals 5. I'm subtracting 1 from both sides. I get n equals 4, and I have m plus 1. Same thing goes inside that blue. M plus 1 goes here. I'm going to subtract 1 from both sides, and notice negative 5, negative 1 makes negative 6. So what this is saying, when we have to account for those 2 different measurements that equals 5 units. And what this is saying is basically that if I put 4 into the absolute value, 4 plus 1 is 5, the absolute value of 5 equals 5. Or if I put negative 6 plus 1 is negative 5. The absolute value of negative 5 is equal to 5. So both solutions work. So we would put those into a solution set, negative 6 and 4. The order doesn't matter, but usually math people like to go least to greatest. All right, let's keep going. So pause it and you try it. Split the equation so that you can account for both positive 15 and negative 15. Now let's check our work. Set 1 equal to positive. When you set it equal to the positive and the negative, you lose the absolute value. And it's an OR situation. And then I'm adding 3 to both sides. And then I'm adding 3 to both sides. And so my two solutions. Now you should be able to check that. Negative 12 minus 3, that is the absolute value of, that equals the absolute value of negative 15, right? And that becomes 15 equals 15. This becomes positive 15 absolute value equals 15. And the absolute value of positive 15, no matter what you do, whether it's positive in there or whether it's negative inside, the answer is always the positive value because it's a distance from 0. So both of those do work. Okay? And it's very easy for you to check. All right, before we can start to figure out our absolute value, we have to kind of treat it like it's a variable and isolate the absolute value. So the first thing we want to do is get rid of that plus 7 using inverse operations. Inverse operations is to subtract 7. Okay, 2x minus 3 is equal to 25. Okay, 2x minus 3 is equal to 25. Now, I'm ready to branch. Okay, so I branch it out. 2x minus 3 equals positive 25. Or let's do it all in black. Here we go. Make it stand out. Or 2x minus 3 equals negative 25. Okay? To lose the absolute value, we set it equal to the positive or the negative. And then we just solve it. Plus 3, 2x equals 28. Divide both sides by 2. Okay, guys, please don't stop here in your work. I'm still finding kids on tests that stop, and I'm not giving you credit. X is 14. I'm adding 3, adding 3. Okay, when we have a negative and a positive, we really subtract. It's 22, so divide by 2, and x is equal to 11. I'm going to put it in my solution set, 11 and 14. And 2 times 11 is 22, minus 3 is 22. That doesn't work. Oh, and I would have to equal this. That still didn't work. Oh, it's negative 22. This would be negative 11. So this would be negative 22. Yep, that works. Minus 3 is negative 25. And then we have 2 times positive 14. That is 28 minus 3 is negative 25. Check, that works. 28 minus 3 is 25. No, it's positive in that case. We had to make sure it worked for the positive, and the negative. Okay, let's keep going. So it should have been a negative 11, not... Let's go what I had. Let's see, let me go back to mine. Oh yeah, I have my negative 11. Okay. All right. Why don't you try this one first? Remember, we have to isolate the absolute value first. So when a number is next to something, a variable or an absolute value, it means multiplication. But we do not distribute. We have to get rid of it. We're trying to get the x alone. So we never distribute into an absolute value. So try this one. All right, so hopefully to get rid of the 3, instead of multiplying by 3, you divided by 3. Do not distribute into. You can never distribute into an absolute value. You have to deal with the absolute value on its own. And now I'm going to set both equal to the positive 6 and the negative 6. And then I'm going to add 4 to both sides. I'm left with x is equal to 10. I'm adding 4 to both sides. I'm left with x is equal to negative 2. And my solution is negative 2 and 10. So I can try that up here. Negative 2. So 3 times the absolute value of negative 2, that ends up being is negative 6 equals 18, and it's 3 times 6 equals 18. So that works. Okay, I can try now the other way, which would be 3 absolute value 10 minus 6 equals 18. So 3 absolute value of 4. Now remember, we have to take the absolute value before we can multiply. So notice I figured out that this was 6 before. I can't multiply 3 times absolute value. We have to get rid of it. So the absolute value of 4 is 4. Now I'm ready to multiply. Oh, that doesn't work. Oh, it was negative 2. That's why. Okay, so I see where I made my mistake. So I really am not using the equation. It's 10 minus 4. So that simplifies to 6. We have to take the absolute value of 6 is 6. And 3 times 6 is 18. So both work. Check your answers. Okay. It's getting a little bit longer, so we've added a couple more steps. Again, your goal should be to isolate the absolute value. Do not distribute. Get the absolute value alone. So step 1, we're going to add 7. It's easiest to undo adding and subtracting first. Okay. Then we undo our multiplication and division, just like multi-step problems. Divide by 2. Never distribute in. And then I'm left with x plus 1 equals 11. X plus 1 equals 11. So I have to set it to x plus 1 equals 11 and x plus 1 equals negative 11. We're going to subtract from the first one. I get x equals 10. Subtracting from the second one, I get x equals negative 12. So my solutions are negative 12 and 10. And again, you could actually try it at this point right here. Negative 12 plus 1 is negative 11. Absolute value of negative 11 is 11. 10 plus 1 is 11. So it's an equivalent equation. And that, my friends, is our lesson. Okay. Pause the recording if you don't want it to end.